SwayamPrabha. Digital India. Educated India.
Hello and welcome to the second module of week 1. So, we will continue our discussion which we started in the first module. So, we talked about what is plastic in the first module. Today, we will try to look at the different types of plastics, and as like you will see that we will talk about plastic from its types based on the different additives in there, different types of usage and all that. So, in the entire week, we will be looking at what is plastic, which we talked about in the first module. Today, we will focus on in this particular video, we will focus on types of plastic, and probably will continue that discussion in the next video as well, in the next module. And then the last two modules will focus mostly on the usage and the global statistics, like how much plastic is really made in global scale and then also in Indian scale. And why we are discussing all this, the course is on plastic waste management. So, the rationale behind having just to look at what is plastic, types of plastics, usage and global statistics is to try to get an idea on how much plastic is really out there, and because whatever waste will be produced will essentially we will be produced from these plastics only, which we are using in different application. So, today's focus is looking at what are the different plastic like a usage, what are the things we do with plastics. So, we make plastic and the usage of plastic, we can classify that based on how we are making products. So, you can make products based on all these different bullet points that you see on this particular slide. You can make a plastic product using extrusion, calendaring, film blowing, injection molding, blow molding, and we will talk about each one of that in little bit detail in subsequent slides. So, don't worry, you will get the explanation as well. So, these are the different ways where how we make the plastic products, and based on the way the plastic product is made, it can be classified into different types. So, it can be expanded bead, rotational molding, compression molding, casting, thermoforming, and many of these bullet points that you are seeing on this particular slide is also used for other types of manufacturing of products, whether it's based on glass, based on certain metals. So, it's many things are common, but of course, there are certain things which we do for plastic which we do not do for other material. So, in the extrusion, how we work with the extrusion, it's essentially you will if you look at the process behind it, you have granules or powders or pellets, which is you put it in a hooper. As you can see on the sketch, we put the material in this hooper over here, and then the plastic pellets are formed, put it in there and fed into this is the extruder barrel. This is a barrel which is an extruder barrel, and as the extruder barrel is turning, it turns and blends and moves the material down the barrel. It's when you say material down, it's not the vertical down, here it's an horizontal down, as you can see in this particular sketch. And then then material then flows through a die where there will be basically that's put it in the desired shape, and it is cooled by water or air, and then it cuts into different length. As you can see, it can be tubings or pipings or sheets or film. So, this is a basically extrusion, like you have a pellets, granules, powder, put it in a hooper, kind of make it semi-solid or liquid kind of form, and then you blend it, put the material down the barrel, put it in a die and put it in desired shape, and you cool it down. So, this is very commonly used, and it's used for all the glasses and other stuffs, the pipes, the folders, as you can see in the picture which on the left side of the slide. And then the limitations is usually it is limited to sections of uniform cross section. So, you need to have, why uniform cross section? Because you already have a desired shape, because you cannot have very variety of shapes coming out from there. Other we use is a calendaring. Calendaring is where you can take a plastic dough and there will be two rollers. The rollers will kind of they will be rolling, as you can see on top. There are two rollers which is trying to make this nice plastic sheet which goes through another roller. So it's like a calendaring, because as you can see on the picture on the photographs, it's essentially you are what you are doing is you make a dough like a very you make a paste, and a thermoplastic mass you formed into sheet of uniform thickness by pass it through a series of heated or cooled rolls, and then it's used. We use this kind of film plastic material either to as a transparency sheets kind of material, or you use it for wrapping. You put some wrapping or lamination, so you can these kind of materials are used. So basically you make you make a sheet material and covering the you can also use it for covering the back of certain plastic. So those things are also used. But many times when we try to have a blended paper and plastic, it is also used over there. But there are, for every process there are limitations. So similarly here we have some limitations that very thin films are not possible. So it has to be certain thickness, because what will happen in a very thin film, it will not withstand the like a stress that goes through this calendaring process, and it may tear apart. So that's why you need to have certain thickness present. Then film blowing, which is again now the another, you can go for like a thinner material. It's here you are continuously extruding vertically over a semi molten polymer. It's like essentially like a fountain, and then you have a bubble layer is maintained. So you are basically stretching the material and try to mix it in a film, as a in particular based on the like a thickness that you require. You go for slight modification in the process, and then you again, since it's a heated up, it has to be cooled. So the problem with this kind of stuff is it's a costly, because the process gets complicated, low efficiency, less accurate process. For this particular course, you don't have to really get into very nitty-gritty detail of how each of one is being manufactured. The reason why we are trying to go over these slides is to give you some idea that there are a variety of plastics out there. So when they come to the waste stream, it is also a variety of plastics which is coming to the waste stream. So when we try to recycle, more and more plastic types getting mixed together, it becomes a problem for us in terms of when we try to go for recycling of these plastic. Mixture of plastic is always, you have to as we say in the waste management sector, as we say in the municipal solid waste, that you have to sort segregate the garbage. Similarly, if you have variety of plastics coming together as a plastic waste, we need to sort segregate the plastic waste types as well. So that's why it's needed, the information is needed to understand what are the different plastic types available in the market, which will essentially come in the waste stream. Then other is your injection molding, which is a very common used for many types of production process for different here it's similar to die casting metal, as you do it for die casting. Again, you have lots of shapes, as you can see on that blue picture with all the different shapes there. It's that's what you have pellets, again plastic pellets melted, where put it in a heated cylinder, melted. The screw is rotating here, as you can see in this particular picture on this sketch, where we have these this is the hooper, this will load it things in here. You have the mold, this is a heater, so things will get loaded up, and here hydraulic fluid is putting the pressure. It goes into this particular mold, it passes through this screw. While it passes through this, there is a heater on top and bottom which melts it, and then it goes into this mold and makes this different, like a beautiful shapes that you see over here. So based on the type of shapes that you require, you can have those kind of molds present. So a screw will rotate much like extrusion molder. It moves back as the material is getting melted, then it ramps forward, pushing the material into the die. So again, what is the limitation for that? High initial tool and die cost, not economically practical for a small run. So, you need to do a massive production of this. So, you will set it up for one particular type of material. As you can see on this picture, there are different types of products, all made from different types of plastics. So, here the thing is that you need to, since you will be working with one particular type of shape at one particular time, you need to produce a huge quantity of that. Otherwise, if you have to change the shapes, this mold very frequently, it becomes more and more costly. So that's a kind of thing is required. Then blow molding, it's used for glass bottles as well, where you will have a extruded tube or expanded. You put some internal pressure and then you blow it. So generally limited to hollow or tubular parts. You can use it for some other mold shapes as well, other than bottles and containers. So most of the bottles here you can see the steps where you will have first heated plastic is extruded into the hollow tube. Then in the second step you will have mold will close, and you will have the grip is in place, the center position is in place. Then you blow it by putting some compressed air, and which will mold into the inflates. Then you have the whole thing will fill it, as you can see from number 4, where things gets all filled up. Then you let it cool, product is trimmed, and then it's cooled. Once it's cooled, you cut it from the top, where the areas that you don't require, as well as the bottom, you can take them off, and then the material is at number 6, it is ready for shipment. This is how the plastic bottle is made. So again, you need to, but again, if you sometimes what we do to make the plastic bottle, usually it is just one particular type. It will be either PET or HDPE most of the times, but or LDPEs as well. But sometimes you may have a blended plastic together, and then in that case the recycling of that becomes a little bit more challenging. And you can have expanded bead blowing, which is another way of you can speak. Here you take a measured volume of beads. You can have a blowing agent, which is usually a gas, usually pentane, dissolved in the plastic, being placed in the mold. Then the closed mold is heated, which will make the plastic soften, and the gas will expand, and the blowing agent will generate the gas. So result is fused closed cell structure of foam plastic that conforms to a shape. So you make so it requires process and material precision, and creates some waste as part of the process as well. It requires a lot of production methods with limited product application. So this type of plastic is used in a very limited application. So it's of course it may become costly as well. Then you may have a rotational molding, where we use for buckets and these trays and the drums, those syntax tanks, or a big water tank that you see, which mostly rotational molding which is used. Here you have you put a predetermined amount of thermoplastic material, powdered thermoplastic material, you pour it into a mold. Mold is closed, heated and rotated in axis with 2 planes until contents are fused to the inner wall of the mold. Then mold is opened and the part is removed. So it's usually it has to be used for hollow parts. So you can ideal for buckets or any container, and production rate is usually slow. But here again you need to have, of course, every process has certain process efficiency, and you have to be careful in terms of have a very nice I would say rotation has to be in such a way so that the plastic really gets very nicely on that mold surface, so that when it cools down you get a drum or which has uniform thickness throughout. So those are process stuff which will not go into detail, which we will not talk about. This is kind of out of scope of this course, but this is how those drums are made. So it's always, as I keep on saying in many of my courses, that it's always better to have some idea about, although we will be worried about when this particular drum ends up in my waste stream, but to have some idea of how this drum was made in the first place is always helps in terms of to see that whether we can potentially reuse it. What could be reuse applications we can have when this drum comes to the waste. Other is your compression molding, where the previous one where we were actually blowing things up and trying to get it on the surface of the mold. Here we are trying to compress. So, here is a thermoset compound usually performed is you position it in a heated mold cavity. You put that in the heated mold cavity, the mold is closed and then you put heat and pressure is applied. The material will flow and fill the mold cavity. So, it will come to the mold cavity, then the heat will completes the polymerization, the part is ejected. So, it is we usually use it for intricate parts containing undercuts, side draws, small holes, delicate inserts, etc. It is a time consuming process. So, it does take time. So, here you are using compression. So, you basically have thermoset compound which you use that put it in the heat mold cavity, then mold you put heat and pressure, it will go into that particular shape and then you use some heat to complete the polymerization and the part will be ejected out. So, that is how it is made using the compression molding. Casting which is again which we kind of use it for many of our production we do in terms of it does for plastic, even for clay, we do it for metals. Casting is very common stuff, a very old way of doing things. So, here any casting, as we know, we have to first make it the liquid. So, liquid plastic, you will have a liquid plastic which will be poured into the mold, and here without pressure cure are taken from the mold. So, you just put into the mold, then you put a thermoplastic film in terms of the high polished supporting surface. This process has you put a large part with thick cross section with good surface finish. So, based on the type of material that you require, of course, you have to get the mold made and you put the molten plastic, liquid plastic in there, and then you the plastic, as it will cool down, it will take the shape of that particular mold. Before you put the plastic, we need to put a layer of material which will keep the plastic not sticking to the mold surface, as we do it for other applications as well. So, since the mold is already kind of predefined, we have the shapes of the material of that particular mold is already predefined. It has a certain limitation in terms of you can make it for certain types of simple shapes. We can except for cast films, method becomes uneconomical at high volume production rate. So, we have to it's for certain material it works fine, but for in general it's a high volume production rate is required, otherwise it become uneconomical. So, we need to produce a large amount of that. Thermoforming, where other method of using it, you use heat a thermoplastic sheet, use a vacuum to pull the sheet over perforated mold, heat softened thermoplastic sheet is positioned over male and female mold, air is evacuated and then forcing sheet to form a contour of the mold. So, here you can limit it to part for simple configuration, you can there is a high script, more waste, limited amount of materials from which to choose. So, you can make a lot of different types of material, as you can see, like a tray and different parts for like refrigerators, different types of containers, and so bowls and like I would say cups and other stuffs, those are made using these kind of techniques. So, again there are different ways of making different types of products. So, based on all these different things that you saw, to make we use if you keep an eye on all the material that you use from morning to evening, from when you get up in the morning and the time you get to the bed in the evening, and in fact, maybe several parts of the bed itself is plastic nowadays. So, we use variety of plastic material and they are made in a variety of way. So, the examples that was shown to you in the slides in this particular module so far was just trying to have an illustration of what are the different types in which a plastic is made, and it's not there could be other ways of manufacturing plastic products as well. These are the I would say most common, most prevalently found methods of making plastic. And as you saw, it's not many of those method is not only unique to plastic, we use it for other stuff too. So and then these different types of products is made using these different methods. So now we will try to look into some into the characteristics of plastic. So when we say plastic different application, since say for example, if you want to have a very heavy duty tray where you will be carrying a lot of soil and other stuff, so you need a really strong material, as opposed to having a I would say just if you want to use it something for single use, small container, or you want to like a film plastic kind of material, or single use like plates. So as you can see, there are lots of plates nowadays which is very thin plastic. So which is essentially single use, or maybe used for a couple of times and then it not used anymore. So what I am trying to say is, based on different types of application, different types of plastic is used, and sometimes the manufacturing methods will also be different. So let us look at some of the characteristics of plastic, and then to see that how the product relates with the different plastic characteristics. So each type of plastic has very distinct characteristic, but most of the, let us look at some of the general attributes, like general properties. It's why plastic is so popular for the first place. So this will kind of try to explain that. Plastic can be very resistant to chemicals and corrosion, so as opposed to some other material. But so we see over say 30 years ago, we had very less amount of plastic, or you can predominantly say essentially no plastic in our day-to-day usage around 30 of maybe 35-40 years ago. Gradually we start, today we cannot even think of our day without using plastic. So it's why it has become so popular. The reason for that, it's resistance to chemicals, resistance to corrosion. It can be both thermal as well as electrical insulators. So it's a thermal insulator. What do you mean thermal insulator means? It doesn't let heat to pass very quickly, and same thing with electrical insulators. It doesn't let electricity to pass it through. Many times that's why you see we have copper wires or the aluminum wires. They have a wrap of those plastic material. So different multicolor, some blue, some green, black, different colors are used for, and that acts as an insulator. So plastic is used as an insulator material for electrical. Have a very high strength to weight ratio. So one of the thing is, for many of the application, if we have high strength but very low weight, that becomes very handy. So that's the positive point in plastic. It's a very high strength material as compared to the weight. It's highly durable, doesn't get bad with water, and have low toxicity as well, unless the problem that we get in plastic is when it's mismanaged, when we are not managing the plastic properly, when things are getting into oceans and the rivers and other stuff. Just last week, I was working with some people from National Geographic, and I'll keep you updated as we move in different weeks if we have some more update on that. So that there a lot of focus around the globe right now is how much plastic is getting into water, because that's because when the plastic gets into water and eventually to sea, to the ocean, in the ocean currents and with all the flows that are happening there, it starts getting into small pieces, and those pieces when it's especially if it's a white kind of in color, very bright color, white which shines on the light, and then the birds think that it's a food, it's a small kind of fish, or even the bigger fishes eat those plastics thinking that it's a small fish, and that becomes a problem. The plastic starts getting into the food chain, and we get worried about plastic showing up in our fish body, and we don't want to consume plastic when we are enjoying the fish. So it's resistant. It does a good thing about plastic. It's a resistance to water as compared to if you look at the other material that are replaced, mostly paper based material, and it has low toxicity unless it starts getting into all those kind of oceans and other stuff where it becomes a problem. Even then it's not it's essentially a mismanagement problem rather than a plastic toxicity problem. Plastics are material with a limitless range of applications. You can make different colors, you can use it for a variety of purposes, as you can see from when we start looking at these material that we use for from as I said, from the toothpaste and toothbrush all the way to your evening stuff, like whether you are even sometimes when you take the medicine, it will be in a plastic container. So it's a variety of application, and the reason for that is it's a limitless range of characteristics. It can fit in at many places in our daily requirement of stuff, and you can make it variety of colors, and it's easy to make. So that's with all that it becomes easier in terms of character. That's why it becomes very popular to use the plastic there. So if you look at the plastic like in kind of what we have talked so far in this particular module, if we would try to summarize and take the discussion in a different level. So plastics, it's there are two major type, you can say, if you look at respect to heating. One is thermoplastic, one is thermosetting plastic. So we used this term earlier as well in the slide, thermoplastic and thermosetting plastic. Then if you think about from a structural, it is either homogeneous or heterogeneous structure, and we'll talk about some of these in a little bit detail, but not too much detail. Just then we have a physical and chemical properties, either it's a soft or rigid or semi-rigid or elastomers, which is like has some elasticity in that, and also depends on type of resin. When I say type of resin, whether it's a PET, HDPE, PVC, LDPE, PP and PS. So what is for PET? It's a polyethylene which we are talking about. That PET is mostly the bottles that water bottles that you use, whether it's a Bisleri, Aquafina and Kinley or whichever brand you buy. Most of the time it's a PET. Then HDPE is those containers where you have the tied detergent containers, Saffola containers and those kind of material, those are your HDPE. Even the plastic bottles, a Bisleri bottles or Aquafina bottle, the cap is HDPE. The ring below the cap, which is actually connected together before you unsealed it, which is a seal, and then while you try to drink it, you unseal it, it becomes it's your HDPE material as well. LDPE, we made some of those some of the containers we make using LDPE. Polypropylene is used, polystyrene is used, PVC is mostly for pipes. So these are the typical, these are the most common ones, and then we use some of the blended plastic together as well, especially in electronics and other applications. So this particular module, what we were trying to look at, if we try to summarize, we started looking at what are the different ways in which plastic is made, what are the limitations of each of the method, just brief overview of how the method works and what kind of product is made using that particular method. Then we also looked at some of the characteristics of plastic, why plastic is so popular and what are the different properties of plastic which makes it popular. Then also looking at the classification in terms of broad classification of plastic based on its heating, based on its structure, based on physical chemical properties and based on the type of resin used. So in terms of the type of resin, we also put numbers like 1, 2, 3, 4, 5, 6, 7, and 1 means it's easy to recycle, and as we increase the number it becomes difficult to recycle based on the available technology today. So whenever you look at any plastic product, look at whether it has a recycling number, and if it's a recycling number, that means based on how close it is to number 1, it kind of gives you an idea of how easy it is to recycle. So every resin has a number, PET is 1, HDPE is 2, and then likewise we have other numbers in there. So with that, let's close this particular module, and then we'll continue our discussion in the next module. One thing I would like to again emphasize that we do have a discussion board going on. So if you have any question, you have any queries, please post it on the discussion board. and that's the mode we will use for communication in this particular class. And again, you will have your first assignment coming out very soon. So go over the video if needed again and again, and all the best, and I'll see you again in next module. Thank you.